Welcome everyone. Today we're going to talk about the chain rule. So that's the discussion of the day. So let's start out with a function. Turn on the pen. And we have the function y equals radical 3x squared plus 9. Let's say we want the derivative of this expression. Well, to do this, recall from our previous video that the first thing I'm going to do, I'm going to start writing smaller, is this is going to be 3x squared plus 9 to the, well, you tell me, square root. There's an exponent rule for that. The square root can be rewritten as the power of 1/2. So here we have an expression y equals parentheses 3x squared plus 9 to the 1/2. How does one take the derivative of this? The answer is in the chain rule. So how does the chain rule work? What the chain rule does is it does an outside-inside approach. It pretends this piece right here, 3x squared plus 9. That's kind of like our inside, our u. And so what's going to happen is that's the inside. We're going to keep that still for now. We're going to pretend like that's a big old u. So really we have the expression u to the 1/2, which means we could do a good old power rule. 1/2, and I like to say leave the inside alone, okay? Just completely don't even pay attention to the inside. 3x squared plus 9. And then subtract 1 from the exponent, like we do when we deal with the power rule, right? It looks like the power rule right now. Bring the power down, leave the inside alone, subtract 1 from the exponent. Now, how does the chain rule come into play? Well, the chain rule comes into play because we have an inner expression. And so what we do is we multiply by the derivative of the inside. The derivative of the inside, and I always am very overly cautious when I take the derivative. I like to take the derivative of the inside and put it inside this parentheses. And so what we have is the derivative of the inside is nothing but the rules we've learned in the previous videos. The derivative of 3x squared will be 6x. And the derivative of a constant is 0. That's why I'm not going to put it over there. And so this is my derivative using the chain rule. It's bring the 1/2 down, leave the inside alone. That's why this is left alone. Subtract 1, and 1/2 minus 1 is a negative 1/2. And then multiplied, I know that looks weird, but that's a multiplication symbol, times the derivative of the inside of this expression. The inside's derivative, remember the power rule, derivative of 3x squared, bring the power down, gives me 6x to the first. The derivative of a constant is 0, and that's why it no longer shows. So there's your derivative. If your professor or the application wants you to simplify, well, here's the thing. First of all, do not distribute inside of a parentheses with a power unless you're really good with exponents. I would state don't do it. But what you can do is you can multiply the 1/2 times the 6x. And that's because of commutativity. A times B times C is A times C times B. You can, because it's nothing but a multiplication, I can take the 1/2 and multiply it by 6x. And 1/2 times 6x, well, 1/2 times 6 is 3. So we get 3x. And then, of course, we have this other expression that I did not change, and I typically do not change because it has an exponent. All right, but from my previous videos, you'll know that I've told you guys I don't like to see negative exponents. And to make this expression into what I call simplified form, the negative exponent will kick this expression to the denominator. Because the negative is on the parentheses, this whole piece comes down. But please, this exponent does not change. Only the exponent that's outside the parentheses will change. So I'm going to rewrite 3x squared plus 9 to the 1/2 power in my denominator. Yes, for those really good with exponent rules, that is the square root, once again, in the denominator, if you'd like to write that as such. Please, talk to your professor, your teacher, to make sure you understand what the word simplified means in your class. All right, cool. The chain rule. What the chain rule allows us to do is to deal with expressions that have parentheses powers. That's really what it comes down to. If I have 10 parentheses, x to the fourth plus x to the 11th power, I didn't have a rule for this yet. And so now I see a parentheses power. Believe me, let me be very clear here. The chain rule is a lot more powerful than what I'm using it for. You could almost call this the generalized power rule because it's more of a function to a power. How do you deal with a function to a power? Well, the chain rule has many, many uses. One of its uses is to deal with what if you have a parentheses to a power? I like to highlight what's inside and say that's just what I'm leaving alone my u. And so when I take the derivative, y prime, I'm once again going to kind of treat this as my u and leave this alone and think of it as 10u to the 11th. And if I just have the expression 10u to the 11th, it's a good old power rule. I would bring the 11 down to multiply. 10 times 11, again, if you need a TI calculator handy, 10 times 11 is 110. Leave the inside of the expression alone. Again, the chain rule is more of an outside-inside rule. The outside function is the power function right now. We're going to deal with the power function first by bringing the power down, leaving the inside alone, and then taking the derivative of the exponent by subtracting 1. All right? We're not really taking the derivative of the exponent. We are subtracting 1 from the exponent using the power rule, so I want to stand corrected there. But because this u right here, this inside, is a complicated expression, we're going to use a chain rule. And so I'm opening up my parentheses for the chain rule. And in this inside, it's going to be the derivative of this is going to be put over there. The derivative of x to the fourth, well, that's a good old power rule, 4x cubed. The derivative of x, that's a sneaky one. Be careful. The derivative of 1x is 1 because the derivative of a line is the slope, and the slope in front of 1x would be 1. And so here is my derivative. To me, this is nice and simple. You could take the 110 and distribute to this parentheses if you like. Please do not distribute the 110 inside of here because of this exponent. Do not. And do not FOIL this out. That's bad too. When you have an exponent, really your simplifying is done except for a few cleanup moments. Again, you can distribute the 110 inside. I would consult, once again, your professor and teacher on how that's to be done. I like this because in future, when we do the applications, when I want to find a max or min, the derivative is extremely important, and I want to set the pieces of the derivative equal to 0. And in this form, I can set the pieces of each one of these equal to 0 a little bit more efficiently instead of if I had this distributed inside. All right, the chain rule, really good rule. When would you use the chain rule? Well, you see it in these two prime examples. If you have a radical, think chain rule. There are other things you could use, but think chain rule because it's really just a parentheses to a power. And that's really the kicker here. If you take your time and look at the two examples I've done so far, you have a parentheses, a function in a parentheses to a power, that's a chain rule. Look down here. A function to a parentheses to a power, chain rule. And that's really what I'm zooming in on, is a parentheses power. There are, again, plenty of other times to use the chain rule, and you'll see that when we see the exponentials and logs and the trigonometry functions, okay? But right now, we are really utilizing it as, in my case, the extension of the power rule. And because this is extension of the power rule, we can play a cool little game with the radicals and fractions. So let's say we have the expression 8 over the fourth root of x squared plus 7. Let's say I want this function's derivative. Okay, so here's what's happening. It is a fraction, and yes, there are fraction rules or quotient rules for derivatives. Please allow me to once again remind you, if you have a constant in the top or bottom, algebra usually makes your derivative process easier. So what I'm going to do is a couple of things. I'm going to kick the 8 off the top, and really I have 1 over this expression. Well, the fourth root is really an exponent, and that exponent is a quarter power. So the first thing I noticed, the fourth root is really a 1/4 exponent. Ah, it's also in the denominator. So what I'm going to do when I rewrite this using algebra, my new exponent will be 1/4, and to kick it out of the denominator, it'll be a negative 1/4. And so this is my algebraic equivalent. This is equal to this. That's algebra. That is not the derivative. Please notice, y equals. I've said nothing about y prime. When you learn the derivative, you have to be very, very careful, okay? And so here, I'm going to make y prime. Now it's derivative time. So let's look at this. Well, once again, my friends, I like to call you my friends. This is our second video together. What we have is just like the previous expressions. A parentheses power. A parentheses power. Oh, look what we have. A parentheses power. Now, that is not always a chain rule, as you'll see in my next video when we deal with product rules or quotient rules, but it is highly suggestible that if you have, well, definitely if you have a constant parentheses power, it is a chain rule, all right? This constant is key. Constant parentheses power is definitely a chain rule, because if you do a substitution here and call this u, you're really looking at 8u to the negative 1/4. And that's really what I'm focusing on, is if I call this u, this thing I've highlighted in yellow, 8u to the negative 1/4 has a simple derivative, a simple power rule. And that's why I'm going to bring the power down. Let's be careful. 8 times the negative 1/4. If you need a calculator, you need a calculator. But 8 times the negative 1/4 is -2. Once again, third example, leave the inside of the parentheses alone. That's our yellow. Leave it alone. Now, so bring the exponent down, subtract 1. Let's be extremely careful here. Negative 1/4 minus 1. I like to leave my exponents as fractions unless there's no choice. So negative 1/4 minus 1 is negative 5/4. That is a 5. Sorry for my handwriting. So negative 5/4. But remember, the chain rule says do the power rule. That's leave the inside alone and then multiply, please. It is a multiplication. Please check your formula sheet, your derivative rules in your calculus book. That is a multiplication. Now's the time to take the derivative of this yellow. The derivative of this inside, well, the derivative of x squared is 2x. And the derivative of a 7 is 0. And that's why the derivative of this yellow piece right there is 2x. All right, time to simplify. Well, really all I'm going to do, I'm going to leave it alone. I like this because, again, I'm going to set this equal to 0. If I was to clean it up, because the professors might want that, these two expressions can be multiplied as -4x. So I guess I said I was going to leave it alone, but I'm sorry, I'm cleaning it up. That's the professor in me. -2 times 2x is -4x. You can multiply these pieces. Again, ABC is ACB. You can commute multiplication. Negative exponent, remember what that means. We can drop it like it's hot and drop it to the denominator. A negative exponent can be dropped to the denominator as a positive exponent. And there is our simplified expression of this derivative. Thank you for watching this video.